Right. Hi guys, and welcome to my talk. So I don't know about you, but on my in my daily work, I'm not inventing new effect systems, or I don't come up with crazy solutions on how to rewrite Zayo or Cards effect or other things. I usually work with simple things like JSONs, APIs, and so on. So in this talk, I want to check and guide you through Scala ecosystem. So I want to answer a few questions. Is Scala ecosystem ready for building fast and robust services? What's the state of the integrations that we have? What libraries out there available? How many options we have? And how fast we can build the business code that we want to. So these guys, they are, people who invent all these libraries that I'm using. They are gods. They know FP, throughout, and they know everything about the functional programming. But that's me, like simpler programmer that is using this libraries that is like a factory worker. Okay, so I'm trying to use these libraries, and I'm not exposing. I'm not trying to understand every single detail of that, or you know internals of these libraries. So I'm a tech leader working at Fintium. For the last 3 years, I've been working with Scala, and I do like to speak at meetup and conferences, and sometimes I'm making some pull requests to open source. So what we usually need in the API layer, we usually need some API definitions. We usually need some codecs and serializers for our entities. We usually want this application to be type safety. We want to have some middleware that will, be responsible for logging things, or maybe some authorization and authentication. We want to have easy testing, metrics, easy functional error handling, and also good performance, fast deployment, and sometimes even like things like WebSockets. So in this talk, we will focus mostly on the API description, creation of the HTTP server, entity serialization and deserialization, and also things like docs, the stability metrics, and HTTP clients that we will use. So there are many options when it comes to servers. 2 or 3 most popular are definitely HTTP4S, Zayo HTTP, and Akka HTTP. So we will focus on the first 2 in this talk. Okay. So HTTP4S is a typeful functional library. So basically, it means that it shares immutable structures. The pure functional side of Scala is favored and promoted to have this composability and easy reasoning about the code, and also it's based on top of the Katz effect. And to support streaming, HTTP4S is built on top of the streaming library called FS2. And it's cross-platform, so it means that it natively builds for Scala.js, Scala native, so you can share the code, deploy to browsers, Node.js, and JVM in general. Okay, so to start with HTTP4S, you just have to import a few things. The main server that you will be using, the entity decoder that you'll be using with that library, DSL, and CRC generic. So there are many options when you want to choose your favorite backend. I'm usually working myself with Ember or Blaze, but if you want to work with JDK client or servlet, it's also possible to choose these backends over the other ones. Okay, so before we start, let's introduce some domain. So let's assume that we have a class called book, and we have the author. So the book has its ID, title, year when it was written, and the author that obviously has its first name and the last name. Okay, we'll also have 2 services, book service and author service, that will generate the logic for us. All right, so So the functional server is a function from a request to the response, obviously, but not every request will have the response. That's why it's wrapped in the option. And also the response can be effectful. So it can talk to database, it can invoke HTTP client that will talk to another microservice, and so on. That's why it's wrapped in the effect type. Okay. So to expose the simplest route of this library, all we have to do is to import the DSL from the HTTP4S and create a partial function that takes a tuple. So the first parameter of the tuple is the HTTP method, HTTP verb basically, and the second part is the root, the URI that we will use in the browser, and then we return some value. Okay, if you want to have some query parameter in your URI, there is this query parameter decoder method that can match any query that you will provide with a simple type. But if you want to also decode your query parameter with a little bit more complex type, like a year in this example, you can create your own implicit and then just provide this to the optional validating query that will be looking for exactly this implicit that we created. That's how we can get this this working and validating our parameter. Okay, so now we have seen the first endpoint. So in the second one, we know that we have this author query parameter measure, and the same for the year. So if we can find the author, then we can fault over the validated year if we have some, and response will be either bad request if the year is not a proper value, or we'll add filter to filter the books by author and by year. Okay, everything is wrapped in the OK that comes with the HTTP4S DSL, and it basically means that it has all the HTTP headers, it has the correct HTTP status, so it's provided by default. We can also see that there is this header the custom header that we want to return with that response. So it's also possible in a quite easy and concise way. Okay, once we have our APIs, we can merge them together by using this operator, or we can also define that if the HTTP route will not be found, we can use this extension method called or not found. So basically, if the user will try to invoke the endpoint that does not exist, we will return a 404 error. Once we have our all routes complete, to have the complete and pure function, then we can create our server. So the server usually contains the runtime context. It requires some parameters like port and host, and requires this routes that we already created. Because this is like a cache resource, we wanted to run forever and exit code as succeed. Okay. So in the previous slide, we have seen the get endpoints. What if you want to do something more, or what if you want to use other HTTP verbs like post or put or delete? So everything comes with the HTTP4S DSL that contains that supports all the HTTP verbs that we will ever need. So let's have a look, for instance, at this post request. So assuming someone will make a post request, the first thing we want to do, we want to decode JSON from the request. So we want to decode this JSON as a book, as our domain level object. Once the book is decoded, we want to call this repository that will save our book to database. And based on the response, we want to return this as a JSON with some location of this of the resource that we created. After all we have to do is to yield the response that will be returned for this endpoint. Okay, so what if you want to add some metrics on top of our application? What if you want to hire Prometheus to do the job for us? All we have to do is to either use metrics module that comes with the HTTP4S and pass to this module the routes that we want to serve with some metrics. If you want to have some middleware, for instance, custom authentication and audit middleware, we can create this one. And now if we want to expose one route, like a status route, to the external world without any authentication, we can do this. But we compose the other routes with the middleware that contains audit routes and contains routes like get events route, get ordered multi events route, and some notification route as well. So these will be hidden behind our custom middleware. Okay, if you want to work with some, login or user cookies or retrieving users, we can quite easily do this using this HTTP4S module and also the crypto sign token that comes from the crypto library to check if the user is audited or user should be restricted to have this in their application. Okay. Once we decided to add other things to our application, like CORS, which is cross-origin resource sharing, and basically it's the mechanism that allows restricted resources on a web page to be requested from another domain outside the domain from which the first resource was served. We can configure that and decide which methods we want to allow to be served and which methods can be called from another domain. Regarding testability, we can easily use any test framework for this, and it works with pretty much everything. All we have to do is to, obviously, because everything is wrapped in the effect type, we have to unwrap this and check either the message or the status or whatever we actually want. Okay, but in this example, you've seen that it's tightly coupled to the endpoints are tightly coupled to the HTTP4S. So if you want to migrate to another HTTP server, it wouldn't be that easy to do so. Obviously, these endpoints are not reusable, and it's not quite easy to integrate them with docs that we would like to have. So there are two possibilities. We either have YAML and a YAML file, and create code on top of that, or we want to create YAML, so the documentation out of our code. But there is some help over there. So there are a few libraries like Tapir, Endpoint4S, or Typed API that can help us doing that. So in this talk, I'll be talking about Tapir, which is type safe, which guarantees that compile time guarantees readiness this library to be used. It's declarative. It has many great integrations. It has a very important trait, which is it's like Tapir is a library. It's not a framework, so it does not require you to change everything to be suitable for Tapir. Okay, so the basic endpoints looks like this. We define the error message. We define the main path in our URI. and then we create the method. We add another path, and we decide what will be the incoming JSON body and the header as well. Okay. Once we have this, we can easily add other things like paging, or we can reuse the base endpoint for other endpoints that we want to have in our API. Okay, once we have this, we can easily do this for the we can easily use this to build our server, because all we have to do is to, same like in the previous slide, define our routes, and then just define the backend that will serve the request. Okay. And here there is another example of how can we couple our endpoint with the server logic. So here we have this endpoint definition, and here we have a logic that will be tightly coupled to this endpoint. And if the security check will pass, if the token is correct, it will return user 123. Otherwise, it will return unauthorized in the left-hand side of the either. Okay. Again, Tapir is quite easy to test. You can do anything you want. You just have to use stub interpreter for this purpose. Okay. Tapir quite easily integrates with OpenAPI. We again just pass the route to this OpenAPI module, and it generates the documentation for us. Same with the Swagger, same definition. We have some endpoints, and we provide them to the Swagger interpreter that comes with the Tapir. Okay, this is the example just to let you know that it's also possible to use with the Zio, and Tapir easily integrates with both HTTP4S and Zio also. Okay, regarding the entity decoders, two most popular are CRC and Zio.json. They have the best performance. So to have the CRC, it basically passes this to the parser that comes from CRC. It can also derive this decoder and encoder for your basic case class. So it's quite easy to work with. For the AP generation, for the AP documentation generation, we have two solutions. But as I have shown you, we will use OpenAPI. Regarding STTP, this is something that will allow us to call another microservice that we have in our system, and we can define this with the basic request. We define the method that we will use, the URI, the content type that we will pass, maybe some authorization token, and the body that we will send to the other service. Once we have this, we can choose the custom backend and use this to send this definition of the request. Okay, once we have this search result, we can do call unsafe runsync on this. We can test again the body and also the status code. Okay, so if you want to work with Prometheus and Tapir, here I'm using the ACA interpreter. We can customize interceptors that we want to use. We can define our own metrics, but Tapir comes with 3 default metrics. So it's quite easy to use them, but it's also quite easy to extend them. Okay, this is the example of how you can create your own counter and pass this to the Prometheus metrics module that comes with the Tapir. We create namespace, we define labels, and register to the default registry. And obviously, then we define how can we increment the counter. Okay, so the stack that I use mostly for the applications, and I think Daniel from Rock the JVM already showed you some of these libraries, It's Tapier with HTTP4S. It's also CRC for decoding things, SSP to communicating to other HTTP services or APIs, Prometheus, and for metrics, obviously, and OpenAPI plus Swagger for the documentation and documentation UI. Okay. Obviously, this talk didn't talk about GraphQL, gRPC, many other things. But considering we have that amount of time, if we would like to go over all these things, it would take, I think, up to 10 hours even. Okay, so special thanks for everybody who watched this talk, for the OSS contributors, because you're building great software that I can use at my daily job, and obviously open source users, because you're the guys who provide feedback, so the OSS contributors can improve their libraries and make it even better. Okay, thank you. And if you have any questions, just let me know. Okay.
ありがとうございました。質問を見ていきたいと思いますが、一つ、しますね。いくつかいただいてます。This one. You showed some code for okay. You showed some code first approach endpoint 4S. Yes, I would like to. What do you think of API first approach like OpenAPI design gRPC or Scala OS?
Sorry, can you repeat the question?
コードのディスコードのメイントラックチャンネル、チャットの方に来ている質問があります。そちらを見てもらいたいです。Just a moment. Okay. You shown some code first approach HTTP and endpoint OS type R. I would like to hear what do you think of API's first approaches like OpenAPI for Gem, gRPC, or SIP4S?
Okay, so I haven't I'm not sure if I understood the question right, but I don't have any strong opinion on the OpenAPI gRPC. I know that there is, if you want to have some documentation from and some library to work with the gRPC in a Tapier-like manner, there is this library called Armadillo, or I think, or it's something similar like that. So it basically allows you to safely and functionally define your endpoints with gRPC. Because if you want to do this with Tapier, all your endpoints will be, will have the same type, and will, if you want to define this, you will. It's not an easy way to define the gRPC method in your Tapier code. But with Armadillo, you can do this, and I think it's like a Tapier for gRPC calls. So that would be if you want to use gRPC and have some typeful and declarative endpoints, I would go for this, because otherwise there is like not an easy way to do this in Tapier. It won't be very functional.
ありがとうございます。他にもですね、質問をいただいているんですけども、ちょっとお時間がなく、ちょっと私もうまく伝えられないので、Discord の方を確認していただけますかね。大丈夫でしょうか。はい。 この質問はディスコード上で、ご対応お願いできればと思います。それでは以上をもちまして、本セッションを終わりたいと思います。ご視聴いただきありがとうございました。
Thanks a lot.